Picture this. It's the morning of October 20th, 2025, when suddenly several widely used services, including Amazon, Coinbase, ChatGPT, and Snapchat, are hit by a massive outage. The cause? A DNS resolution failure in the AWS North Virginia region disrupted communication between several AWS services and triggered a chain reaction across the cloud. As a result, multiple businesses experienced downtime and service disruption for hours. Some people say that it was because Indian engineers took the day off for Diwali celebrations on October 20th, but that's not true. It's just a joke. If you're a startup founder, IT manager, or just curious about cloud tech, stick around. This could save your business big time. I want to explain what happened and how you can make your business more resilient to these kind of incidents that affect thousands of businesses. It all began with a simple DNS lookup failing for the Amazon DynamoDB API endpoint. If you're familiar with the AWS global infrastructure, you might be wondering, well, why, if this issue happened in Virginia, why did this break things globally? Why couldn't someone in Tokyo do something as simple as updating user permissions or simply logging into their account? Well, this happened because US East 1 or North Virginia is not just another region in the AWS global infrastructure. It's the oldest and biggest AWS region, and it hosts the main control planes for many AWS global services. The control plane is like the management office, and the data plane is where the data lives and the actual work happens. These control planes are responsible for managing configurations and orchestrations across regions, so when they become unreachable, operations in other regions can also fail, even if their local infrastructure remains intact. In essence, the outage in Virginia took down both a local region and what we can call the global headquarters. Other AWS regions were still operational, but no one could perform administrative tasks. For hours, you couldn't log into the main AWS console or create a new user or maybe update a security policy from anywhere in the world. This is how a regional technical fault became a global administrative crisis, exposing what many people call the Achilles heel of the AWS global architecture and resulting in millions of dollars in losses due to downtime alone. So, what's the real lesson here? Is it time to abandon the cloud and go back to running servers in our office closets? Absolutely not. That'll be like seeing a major highway pileup and deciding the solution is to go back to riding a horse. The problem isn't the vehicle, is that we need to learn defensive driving. In cloud terms, that means designing for failure, implementing redundancy, and understanding the shared responsibility model. In fact, managing your own physical servers in one location creates the ultimate point of failure. AWS resolved the core DNS issue in about 2 hours and 35 minutes. But if you're running your own hardware, a power outage, a flood, or simple hardware failure could wipe your business offline for days. The cloud isn't the problem. It's a powerful tool that gives us access to global infrastructure we could never build ourselves. The key takeaway from this outage is that we must design for failure. You have to architecture systems with the assumption that things will break. The question isn't if things can break, but when and whether your business is prepared. That preparation starts with two fundamental concepts that every business owner and tech leader needs to understand: high availability and disaster recovery. High availability is about surviving small failures within a single location. Maybe a server rack failing or a power issue in one data center building. It's like having a spare tire in your car. If you get a flat, you can swap it out and be back on the road in no time. The goal here is to ensure your application and business continues running with minimal or zero downtime despite these smaller failures. The most fundamental practice for high availability on AWS is not to put all your eggs in one basket, or in this case, in one availability zone. An availability zone is a data center or multiple data centers in a location within an AWS region. These data centers can be miles apart from each other, but close enough for fast communication, and they have independent power and networking that isolates them from issues in other availability zones. So instead of running all your servers in one availability zone, you spread them across at least two or three. You then use a load balancer to distribute incoming traffic across all instances in all active zones. If one entire availability zone has a problem, the load balancer will detect this and will send your traffic or customers to the healthy instances in the other availability zones. Your customers will never notice a thing, believe me. This is the single most important and cost-effective step you can take today to improve your business resilience. On the other hand, disaster recovery is about surviving a much bigger issue, like an entire region going offline. A spare tire won't help you here. Disaster recovery is like having a second car parked somewhere else in a different city, waiting for you, ready to go. The goal of disaster recovery isn't necessarily zero downtime, but to restore your business operations as quickly as possible in another location with minimal data loss. This is why multi-region architecture needs to be the default thinking if you want your business to be resilient. It cannot be an afterthought. Before choosing a disaster recovery strategy, you need to answer two critical business questions. Number one, what is the maximum amount of time your business can be offline? An hour? A day? This is called Recovery Time Objective, or RTO. Number two, how much data can you afford to lose? 5 minutes worth? An hour's worth? This is called the Recovery Point Objective, or RPO. Your answers will determine which of the following strategies is right for you. The most basic and cheapest strategy is called backup and restore. This is where you take regular backups of your most critical data and copy them to a second region, and in case of a disaster, your team would manually restore everything there. A step up from that are the pilot light and warm standby strategies. With a pilot light, only your most critical data, like database replica, is running in a second region, and your application servers are off until a disaster happens. On the other hand, with a warm standby strategy, a small, scaled down version of your application is always running in a different region, ready to scale up. Both options offer a great balance of cost and fast recovery. The final strategy is active-active. This is where you run a full active deployment of your application in two or more regions simultaneously. Both regions are serving live user traffic all the time. If one region fails, Route 53 health checks detect that and automatically send all traffic to your other active region with virtually no downtime. Finally, you need to understand that a disaster recovery strategy that you have never tested is not a plan, it's just a theory. You need to break things on purpose before the actual disaster happens, because a strategy is not enough if you haven't tested it. You can use tools like the AWS Fault Injection Simulator to simulate an entire region vanishing and verify with confidence that your load balancers, data failovers, and multi-region routing works exactly as you designed them. If you really want to make your business more resilient, you can book a consultation with us and we'll help you out no matter how big or small your organization is. Thanks for watching. We have covered a lot of ground today, from high-level strategies to specific tools. To help us create the most valuable content for you, Let us know what you'd like to see next. Write in the comments if you want to learn how to set up a multi-region warm standby architecture, or how to configure Route 53 for automatic failover, or how to run your first chaos engineering test. See you next time.